So, what we have found that periodogram is something which can replace now our old PSD and give us the benefit of directly using the data to compute the PSD. So, now we try to make it more convenient. Instead of taking the sum from minus m to plus m, that means a centered data which is somewhat artificial, we would like to actually change the indices for the data set usually given in the form starting from 0 to n minus 1. That periodogram form would be a little different. We would compute the sum n equal to 0 to n minus 1, that Fourier kernel would be there along with the term x n, and we will take mod square of the summation, and again we will take the scaling factor 1 by n like the previous one. Earlier we also had that 2 m plus 1, that is the number of terms we are adding. Here it is 1 by n, so many terms we are taking. And for the practical use, two more things are done, that is we have always limited data. So, and we have used all of them, 0 to n minus 1 data was there, we have used all of them. So, there is no point in keeping this term. So, this limit is dropped to make it usable. And next thing is that expectation operator, this is also is a difficult thing, that we told that what is the meaning of expectation operator. We need to do multiple experiments if there is a luxury of that. For example, if we can have multiple coins, we can try them at a time to find out what is the probability of getting the head, and we can collate all the results that will give us the effect of expectation, that averaging in the random space. But in practice we are actually most of the time left with one single actually set of data. Okay. So, we do not have the luxury to do the averaging over that random space. So, we simply drop that expectation operator, and earlier in case of the LMS algorithm we have done that, and we have found that it did not give very bad result. Okay. Maybe that has encouraged us to do that. So, we get a somewhat working definition of the periodogram here. Okay. We get a working definition of periodogram, what we can use for the day to day work, and with that we proceed. Now, the question that comes to us, that what is the interpretation of periodogram estimator at a given frequency. We know that PSD is defined in such way, and PSD has an interpretation. It is PSD gives us the energy at a particular frequency, but periodogram is somewhat different, though they have a relationship. When we can take those limiting condition m tends to infinity and taking the expectation operator, we can show it is same as that classical definition of PSD, but in practice we do not have them. So, still can we get any interpretation of this periodogram in the frequency domain? That means, for a particular value of f, what the periodogram value or the estimate will give. And here to actually signify that here it is an estimate, we have used actually this hat operator. You see over the p we have used a hat. It is just to signify that this is an estimate. Okay. So, what is the meaning of it? We would like to know that. So, we will do some more small derivation for that. The periodogram we will rewrite in a little different way. What we will do? We will write it instead of the exponential term directly, we will write it in the form of a convolution with that an impulse response h n, where h n has the terms 1 by capital N exponential j 2 pi f 0 n for the minus lags starting from minus n plus 1 to 0, and it would be 0 for the other lags. Now, here we have chosen a particular frequency f 0 for our actually derivation. However, it could be any frequency, but at this moment we are just trying to concentrate that at a particular frequency, if we can find the meaning of the periodogram estimate, then we can generalize it, we can compute it for any other frequency. There is nothing more in this use of the term f 0 instead of f. Okay. So, it is just to tell that at this moment we have chosen a particular frequency and it is not a variable at this moment. Okay. We are dealing with other variables to compute the value of the periodogram estimate at this fixed frequency f 0, which is arbitrarily fixed. So, if we need, we can change it. So, now we get that h n is the impulse response of the linear shift invariant filter with some frequency response. So, we can write it in this way, that we can take the Fourier transform of h n to find out the frequency response, and what we get, that we have some term here, that is sinc function, and then we have an expression here exponential j n minus 1 pi f minus f 0. Okay. So, that gives us the term. Now, what we get, interpret from here, that h n is a band pass filter centered at f equal to f 0. From these actually we are getting it, that it is centered at f equal to f 0, and we get that h n is located at frequency f equal to f 0, and the periodogram estimate from here what we get gives the power at f 0 by filtering data with a band pass filter. That we have the data, the samples, and from there we have computed the squared magnitude of that. The filtered output, if we sample and take square, that output is giving us the value. That means, we are getting the energy if we apply a particular band pass filter which is centered at f equal to f 0, the energy at f equal to f 0 of this particular band pass filter. Okay. So, we get some idea that what we are expected to get out of our data, and we get some more thing from here. The term n, that capital N, which gives the number of samples, this factor is necessary to account for the bandwidth, that how wide or narrow would be that band pass filter, that is determined by n, and we get the 3 dB bandwidth of that band pass filter. It is proportional to 1 by n. So, what we get, if we have more and more data, then that bandwidth would be smaller and smaller. So, it will slowly converge towards the impulse function in the frequency domain. So, if we could have infinite amount of data, it could give us the exact energy at frequency f equal to f0, and that is true for any f0. So, what we get with finite amount of data, periodogram gives us the energy of the band pass filter with certain impulse response, that is we have given here, and around f equal to f0, and as we have more and more data, it will go towards the ideal condition that band pass filter will collapse towards a delta function, and it will gives us the exact energy at that particular frequency. Okay. So, it is moving towards the ideality. So, that is the second actually result we get, and that gives us much hope about the periodogram. Now, here we will take a small break to absorb this idea, and again we will come back soon. Thank you.